In this video, we're going to be discussing how to solve this problem in Algebra 1 on quadratic equations and quadratic graphs involving circles. So here's the problem statement. The graph of y equals 3 times x minus 5 squared minus 75 has an x-intercept at a, 0. Find all values of a. So we have our complete equation right here, and this is actually called standard form, and standard form allows us to represent the graph of a circle as a equation with a squared term like x minus 5 squared here in parentheses. We aren't actually going to really need to do any graphing here for this problem. That's not part of what we need to do. In fact, this is actually quite a simple problem if you know a shortcut on how to solve the question for a. So they want to know all values of a. So we're going to go ahead and go through the first step here. When we want to find an x-intercept, the first step we always need to do is set y equal to 0. Because in any situation, an x-intercept is going to have a y-coordinate equal to 0, like it is up there in the problem statement. So first step, set y equal to 0. So if we do this, our equation becomes something entirely different. We would have 0 equals 3 times x minus 5 squared minus 75. So that's a little bit different here. We have 0 now, and what this allows us to do is find the value of x easier. Now, in fact, from here on out, we should change x to a because we're trying to figure out all values of a. We're no longer solving for x. We're solving for a. So to be more consistent here, we can rewrite this same thing as 3a, because this is going to help us keep track of where we're going. It's the same exact equation. Okay, so we have this revised equation now, set equal to 0, and we want to know all values of a that make it equal to 0, essentially. So we've got this minus 75 here. That means that's telling us that this product over here, 3 times a minus 5 squared, has got to be equal to 75, because 75 minus 75 is 0. So we need to find a value of a that makes 3 times a minus 5 squared equal to 75. And put another way, we could also say a minus 5 squared is equal to 25, to make it even simpler, because 25 times 3 is 75. Alright, so this is a really simple equation here to solve. All we have to do is just think about the solutions here. Square root of 25 is 5. That means our value for a must be 10, because 10 minus 5 squared is 25. So that tells us one value for a is 10. Now we're dealing with squares here, and whenever we have squares, we might have, or actually we pretty much always have, a second solution. And in this case, our second solution is going to be a equals 0, because a minus 5 is negative 5, and negative 5 squared is 25, just like with the a equals 10. So we have two solutions here, because you can square a negative number, and you get the same result as squaring the same positive number, negative 5 squared and 5 squared. Same thing there. That's how you would work out that. So we've got two values for a now, 10 and 0. And if we really wanted to be sure, we could plug that into the original equation up here, the very first one we solved, the unmanipulated one, so to make sure everything's all right. So we could test a equals 10, or x equals 10, as it was back up there. Plug it in, 10 minus 5, 5 squared, 25 times 3, 75. 75 minus 75, 0. That makes y equal to 0, as it is in the problem statement. Testing a equals 0, we have 0 minus 5 is negative 5. Negative 5 squared is 25, and the same exact thing as the other solution. So we found our two values for a here. These are the only two that exist, and that's exactly what the problem asked for. So that's how you would go about solving a problem like this concerning quadratic equations and circle graphs. We didn't actually have to do any real graphing here, because there was no need to. All we had to do is simply do some manipulation, setting that y equal to 0, and then do some simple equation solving, because we knew this inner part here had to be equal to 75, and the a minus 5 squared had to be equal to 25. So that's how you would solve that problem from Algebra 1 on quadratic equations and graphs.